Welcome to my project bazaar.com.
Let's see the title of our project. Our project title is Active Learning of Constraints for Semi-Supervised Clustering. Let's see the abstract of our project. So in this project, semi-supervised clustering aims to improve clustering performance by considering user supervision in the form of pairwise constraints. In this, we study the active learning problem of selecting pairwise must-link and cannot-link constraint for semi-supervised clustering. We consider active learning in an iterative manner wherein each iteration queries are selected based on the current clustering solution and the existing constraint set. We apply general framework that builds on a concept of neighborhoods where neighborhoods contain a label of examples of different clusters according to the pairwise constraints. Our active learning method expands the neighborhoods by selecting informative points and querying their relationship with the neighborhoods. We further introduce a selection criterion that trades off the amount of uncertainty of each data point with the expected number of queries required to resolve this uncertainty. This allows us to select queries that have the highest information rate. We evaluate proposed method on the benchmark datasets and the result demonstrate consistent and substantial improvements over the current state of the art. Let's see the data flow diagram of this project. So first we load the dataset, second read the dataset and view the contents of this dataset. Another one is to view the property view of this dataset. Next, splitting the data and store into the tables. After that, we using a for clustering method to cluster these datasets. First one is random method clustering, another one is min-max method clustering, another one is hang method, and finally NPV method clustering. So in random method clustering with the neighborhood algorithm. So cluster some random points to view the some informations. So another one is min-max method. So we are using a minimum and a maximum values to clustering from the datasets. Another one is hang method. In this hang method, so we add the constraints and split the tables. After that, we store these data to the splitter data. So finally, we clustering from the relations to using the must-link or cannot-link constraints. Another one is NPV method. In this NP method, we are find the normalization of the normalized value of the each clustering performance values. After we finally using evaluation criteria. In this evaluation criteria, we using a F measure method to find the F measure functions of the each clusterings. So finally, we generate a graph to comparison of the four random methods. So in this project we contains following models. First one is accumulating data. So another one is random method clustering. Third one is min-max method clustering. Another one is hang method clustering. Harmonized point uncertainty method. Finally evaluation criteria. This accumulating method. This is the module which is used to enter the data into our process. Here we had the user sample data set as a product details and the online buyer details. The data can be entered and viewed in a structured format in this module. So another one is a random method module. In this module, we using the technique of a simple random sample of the group is selected. Then the required information is collected from a simple random sample of the elements within each selected group. This may be done for every element in these groups or subsamples of the element may be selected. So in this method we are using some data points to cluster the data from the existing dataset. In this method that cannot contain any constraints or classes to cluster the data. In this method the user enters the random points to cluster from the data family and the data stored to the users. In this method the clustering process that show the all data between the two random points. So another module is a min-max method clustering. This module that is very important in the data mining to the knowledge discovery area, as it can be used as a basis for the most complex and powerful methods. One of these techniques is the maximum likelihood, and its main goal is to adjust a statistical model within a specific dataset, estimating its unknown parameters, so the function that can describe the all parameters in the dataset. In other words, the method will adjust some variable of statistical model from a dataset or unknown distribution, so that model can describe each data samples and estimate others. It was realized that the clustering can be based on the probability models to cover the missing values. This provides insight into when the data should conform to the module, and has led to the development of the new clustering methods such as expectation maximization, that is based on the principle of maximum likelihood or the observed variable in the finite mixture modules. So another one is hang method. So in this method, the constrained clustering is a class of semi-supervised learning algorithms. Typically, constrained clustering incorporates either a set of must-be constraints or cannot-be constraints, or both. With a random forest algorithm, both a must-be and cannot-be constraint define a relationship between two data instances. A must-be relation should be associated with the same cluster. These sets of the constraints act as a guide for which a constrained clustering algorithm will attempt to find clusters in dataset which satisfy the specified must-be and cannot-be constraints. So final module is the NQ method for normalized point consistently. Semi-supervised learning is a class of supervised learning tasks and techniques that also make use of the unlabeled data for training, typically a small amount of labeled data within a large amount of unlabeled data. Many machine learning researchers have found that the unlabeled data, when used in conjunction with a small amount of labeled data, can produce a considerable improvements in learning accuracy. The cost associated with the labeling process thus may render a fully labeled training set infeasible, whereas acquisition of unlabeled data is relatively inexpensive. In such situations, semi-supervised clustering can be great practical value. So semi-supervised learning is also the theoretical interest in the machine learning and as a model for the human learning. So let's see the demo of our project. So this is the starting page of our project. First we load the dataset from that is saved from our storage. So click browse button. So we are using a UCI dataset cart. So click this cart. So record inserts. So extra data, we have the properties and file names of this dataset. So files is 18 KB, file name hard disk, number of records. So if you want to see the records in this dataset, click list. So the data will be listed. Another one is show records. To view the all records in the dataset, click this button. So after that, the main module of this our project will be displayed. This module that contains the random method clustering, min-max method clustering, hang method, another is NQ. So click random method clustering. So after clicking, we enter the some two random data points to cluster the data from this dataset. So for example, T. So data will be clustered. So after we want to calculate the evaluation criteria for this clustering, so click calculate. After the calculation, the evaluation F measure value will be displayed is here. So the evaluation value for this random method clustering 0.96396. So click next. So after that, the generate graph of the random method. So click generate. The graph will be generated. The total number of records is 3301. So the F measure value is between the 0.8 and 1. So click home button. So click min-max method clustering. So click clustering. The minimum age will be displayed cluster. Another one is maximum. So maximum age will be displayed. So click calculate. So the F measure will be displayed in this field. So click next. After that, we generate a graph for the min-max method. So first one is a random method, another one is min-max method. Home. So using hang method clustering. So first, the dataset will be split into stored in the three different tables. So click show records. First one is table 1, another one is table 2 with constraints, another one is table 3 with constraints. Click next. So cluster data using a must link and cannot link constraint. So click cluster. So some set of data will be clustered from the 3 different tables. So calculate the NMI value. So the NMI value is 0.6. Click next. So generate a graph for this. So this one is a hang method. This values information rate is very high. Okay, so click home button. The final method is NPU method clustering. So click age to cluster from the dataset. Click cluster. So the data will be clustered. After this, these cluster data will be stored in the another table. After that, enter the another for pairwise constraint data to cluster the data from the previous cluster details. So click the pairwise constraints data information to cluster from the cluster data. So click cluster. So now we have the accurate information read from this NPU method. Calculate the F measure value. So the information is 0.061. This is the information accurate. So we have generated the graph for the 4 methods. So we have the NPU method is a high information that, because we have the information very low information that we have is finally is the accurate information. Thank you.